Okay, I almost made it. I was really trying. I really wanted to get all this done in one video, but guess not. So, the combined gas law. This is out of the four laws we're going to talk about. This is the law that is actually given to you in your reference tables. So, this is a combination. If you take Charles' law, Boyle's law, and Gay-Lussac's law and put them all together, you will have the combined gas law. Hence the name, the combined gas law. So, and this is the law that you would use when all of your variables are changing. So, if your pressure, your volume, and your temperature are changing, you will use the combined gas laws. So this is our combined gas law. This is the equation for it. It is P1 times V1 over T1 equals P2 times V2 over T2. Even though this equation is given to you in your reference table, I still suggest that you write it down. Okay, so moving on to examples. So we have a 15-liter cylinder of gas at 4.8 atmosphere pressure at 25 degrees Celsius. It is heated to 75 degrees Celsius and it's compressed to 17 atmospheres. So what is our new volume? So in this case, we have everything changing. And we are trying to solve for our V2. So we're trying to solve for our final volume. So the first thing, we want to make sure that all of the units for our volumes are matching. So we see that we are given 15 liters. So our first volume is given to us in liters. And then our second volume, we don't know. We have to solve for that. So we're good with that. It's only one volume unit, so we're fine. So then the second thing we have to do, we need to make sure that our pressure units are matching. So initial pressure is 4.8 atmospheres, and our final pressure is 17 atmospheres. So our pressures are good. They match up. So now what we have to do is we have to convert all of our Celsius into Kelvin. So we're going to start with our initial temperature, or our T1, where we have 25 degrees Celsius. Remember to go from Celsius to Kelvin, you just add 273. So 273 plus 25, that is going to be 298 Kelvin. And now we got to do the same thing for our T2, which is 75 degrees Celsius. So we'll just take 75 plus 273, and that's going to give us 348 Kelvin. So that is our T2. So we're going to plug all of our variables in to, let me put these up, plug all of our variables into our equation. Remember, our P1 is 4.8 atmospheres, our V1 is 15 liters, and our T1 is what? Hope you said 298, because it is 298. So now let's go over to our final side, or our 2 side, where we have our P2 is 17 atmosphere. Our V2 we do not know, but our T2 is 348. Doing simple algebra, we're just rearranging this equation to solve for V2. And once we do that, this is how your equation could look. If you do it differently, that's fine too. So we'll have our, I'm not going to go through it, but so here's our V2. We're just going to isolate our V2. So we're going to divide both sides by whatever this is together. And so, yeah, so we're going to divide both sides by 5,066. And then we have our V, move away. Anyway, our V2 is 4.9 liters. All right, next problem. 6.2 liters of gas at 723 millimeters of mercury. That's another measurement of pressure. At 21 degrees Celsius, it's compressed to 2.2 liters at 4,117 millimeters of mercury. What is the temperature of the gas? So we are trying to find our what? What are we trying to find? Right, we are trying to find our T2. So we're going to convert our Celsius to Did I say T2? Yeah, we're trying this out. Yeah. So we're going to convert our Celsius into Kelvin. This should say, oh yeah, so that's the question. Sorry. All right, so that's it for today. Sorry about that last one. But yeah, so that's it. So hope this was helpful. Make sure you take good notes on this, and we will do the rest of the activities later in class.